Yes.
Start, sir. That's
Hello. Okay, right. Okay, I'm starting now. Okay. Welcome to our webinar classes. This is Kishan Reddy from Tsrs Borabanda Boys. So it's in the previous classes we completed one of the conic section is parabola. Now we can start. Now today's class is ellipse. So for that one, so class ellipse class 1. So what is mean by ellipse? First we discuss in the conic section. So we discussed in the conic section, that is, so which is having the 4 plus 4 marks in weightage of IPE. And so observe this figure, students. So this is already in the conic section, but once again I'm repeating this one. So this is axis, this is vertex, this is angle of vertex with the axis. So then this is the figure. So here just red lines are, these red lines are called, these red lines, generators, and this is directrix, this is vertex, and this is vertex angle, this is axis. So similarly here I'm cutting with a plane. What does I mean by conic? A double napped cone cutting with a plane. A double napped cone cutting with a plane, this is called as a conic. So the plane having the some angle, if it is 90 degrees, that will be form a circle. If alpha equal to beta, that is parabola. If parallel to axis, that is hyperbola. If alpha is less than beta is less than pi by 2, which is nothing but ellipse. So like this. Here this is alpha value and this is beta value. So this beta value should be lies between alpha and pi by 2. Alpha and pi by 2. Alpha which consisting the angle. So which means this is called ellipse. This is called ellipse. So we are entering to ellipse definition. So ellipse. So definition of the ellipse: a conic with eccentricity less than unity is called an ellipse. A conic with eccentricity less than unity is called as an ellipse. So eccentricity means indicating with E. So the value is E is less than 1. Unity is nothing but E is less than 1. Okay. So then that is a conic with eccentricity less than 1, less than unity is called as an ellipse. So next, so an ellipse is the locus of a point whose distances from fixed point and a fixed straight line are in constant ratio. So what is saying that in ellipse, okay, sorry, in ellipse is the an ellipse is the locus of a point whose distance from a fixed point and a fixed straight line are in constant ratio E, which is less than unity. That fixed point is called as a focus and a fixed straight line is called as directrix. Okay, respectively. So from conic section, we know that SP by PM equal to E. That is nothing but we know that an ellipse E is nothing but like this in this figure. So here angle alpha and this value is beta. Okay. Observe this figure. So this is beta, this is alpha. Next, this is called alpha is less than beta is less than pi by 2. Alpha is less than beta is less than pi by 2. So this is ellipse. Next. So a second degree non-homogeneous equation, which is nothing but ax square plus 2xy plus by square plus 2gx plus 2fi plus c equal to 0. This is called as a non-homogeneous second degree equation. So I'm saying if it is a ellipse, I want to say it is a ellipse, then it has some conditions. That is, this is the second degree non-homogeneous equation and it represents an ellipse if the condition is delta is not equal to 0 and h square minus ab should be less than 0. H square minus ab value should be less than 0. This is called as an ellipse with a second degree non-homogeneous equation, where delta is equal to, where delta equal to ABC plus 2FGH minus AF square minus BG square minus CH square, which is equal to 0. Sorry, this is not 0. So this value is no there. So this is the delta value. So ABC plus 2FGH minus AF square minus BG square minus CH square. Okay. So then this value indicating delta. Okay, next. So equation of the ellipse in a standard form. So as well as we are proved equation of the ellipse parabola in the previous sections. So now proof. So this is a figure. Please observe this figure, students, and also this is in the figure of textbook, from textbook. So here this is a center. This is a one of the focus, and this is on one of the focus, and this is perpendicular line P2, perpendicular line to the M dash. So and this is Z dash, Z x-axis, y-axis. This is the minor axis, major axis. I will discuss later minor, major. So next, so here proof. For this proof, let S be the focus, E be the eccentricity, and the L equal 0 be the corresponding directrix. I am taking S be the focus, S be the focus. So here S be the focus. So then these are two focus. Eccentricity E and L be the directrix. These two are directrix. So PB any point lies on the ellipse. Let MZ be the projections of P and S on the directrix. L equals 0. Projection is nothing but the extension. So N be the projection of P on SZ. This is the N is the projection of P and with which is perpendicular to the SZ. So let A and A dash be the points which is divide SZ in the ratio E is to 1. We are taking SZ. So A and A dash be the points which is divide SZ in the ratio of E is to 1 internally, externally, respectively. So SZ means this is internally, this is SZ, this point is externally. So here A dash, this length, sorry. So here this length is 2A. Let's see with the midpoint of A dash. So and a line perpendicular to it as C as y-axis. This is a perpendicular line. And consider CZ extended. CZ extended the line as x-axis. CA equal to the distance between CA equal to the distance between CA dash. Okay. So then show that this is value is A comma 0. This value is minus A comma 0. All of you getting? So let CA equal to A equal to CA dash, and A value is A comma 0. A dash value is minus A comma 0. So we know that the ratio formula. So we are saying that A dash dividing SZ in the ratio of E is to 1 internally and externally. So that's why I'm taking. So this is P by PM is not correct. So this is here SCA by AZ. This is not. So SCA by AZ equal to E. SCA by AZ equal to E. SCA dash by A dash Z. So from the figure, this is A, this is A dash. This is A dash I'm taking. This is A. So this is Z I'm taking. Here S. This is S dash. And this is C. This is y-axis C. Center. So here, so what is saying? A SZ dividing with A E is to 1 ratio. That is SA by AZ equal to E I'm taking. And similarly, this is externally, this is internally. Then SA dash by A dash Z equal to E. Then SA equal to E AZ. Just to cross multiply this one. you will get this one. This is the equation number 1 I'm taking, and the SEA dash equal to EA dash. SEA dash equal to SEA dash equal to EA dash Z. So now SEA dash. So here I'm doing 1 plus 2. So equation number 1 plus 2, then SEA plus SEA plus SEA dash. So here S, this is A dash, so SA dash, S dash, this is S, this is A, and the last one is Z, and the mid one is C. So this is EAZ, EA dash Z. I'm taking A dash, SEA plus SEA dash, SA this length, and SEA dash this length. This is nothing but this total length. I'm taking this is A dash. That is, I'm taking E taking common, and the right side I will get AZ plus A dash Z. AZ plus A dash Z. Next, so 2A. I'm taking this length as 2A. What is nothing but A as a this length is A. Why? Because of this value is A comma 0. This value is minus A comma 0. Find the length between A dash. Then you will get 2A. Then E equal to C AZ. AZ came right. I'm writing AZ as CZ minus CA. I'm writing. So CZ, this total length minus this total length, I will get only this length, that is nothing but AZ, and A dash Z. A dash Z means A dash Z. A dash Z. This total length, I'm writing this is A dash C plus CZ. A dash C plus CZ. So this is I'm writing, and this is nothing but this length equal to this length. CA dash equal to CA. So that is the length is same. So that's why I'm writing this will be get cancelled. I will get CZ plus CZ 2ZZ, and 2A equal to E of 2 of CZ. That is nothing but CA equal to A dash C. So that is A equal to, I'm cancelling also 2 here. So then A equal to ECZ. A equal to ECZ. So then CZ equal to A by E. CZ equal to A by E. But this line Z, a line passing through from the Z, that is the directrix. This is the equation of the directrix, and this length is nothing but X, that is X equal to A by E. This is the equation of the directrix. So this is the solving of the directrix. So first we have to take the ratio. So ratio, then we'll get this equations SA equal to EAZ, one equation SA dash equal to EA dash Z, then equation 2, then just 1 plus 2. Then you will get, so these values as per the diagrams. So next, so this is 1 plus 2. Here I'm getting, and I'm next going to 1 minus 2. So 1 minus 2. This is SA dash, SA dash. Similarly, this is Z, this is A, this is S, and this is C, and this is S dash, and this is A dash. So just we are taking this one only. So here SCA dash minus SCA. SCA dash, this is 2 minus 1. This is 2 minus 1. 2 minus 1. Then we'll get EA dash Z minus EA Z. Then SCA dash I'm writing similarly in the previous, A dash C plus CS. A dash C plus CS. This value. A dash C plus CS. This is nothing but SCA dash. Okay. SCA means this length. This length I'm writing CA minus CS. CA minus CS, and the right hand side value taking E as a common, eccentricity as a common. Then you will get this. These two are same. So this is negative value, this is positive value. We can get cancelled now. This, as like this. So 2CS equal to EAA dash. What is mean by a dash? This is nothing but length of 2a. So then 2cs equal to a of 2a, that is cs equal to ae, that is cs equal to ae. Then ae, so ae where is slicing? This is the focus. cs distance between from here, this is a ae, so that is ae. Where the center is 0 comma 0, then this will be ae comma 0, ae comma 0. So this is ae comma 0, which is focus. So focus is ae comma 0. First one we are doing that, and 1 plus 2 will get sz, I mean cz equation, that is nothing but directrix equation, and the 2 minus 1 will get focus, that is ae comma 0. So I'm taking a point P lies on the ellipse, that is x1 comma y1. Then we know the conic formula. SP by PM equal to E, and which is less than 1, that is called ellipse. That is called ellipse. That's why we are taking that one. And before that, I'm taking PM equal to here from the diagram, PM equal to. So this is like this, sorry. So some thing is, this is PM, P, and it's a perpendicular line N in the figure. Please observe that one from the textbook. And this is M, this is M dash. So this is PM equal to NZ. This is Z, NZ. This NZ can be written as CZ minus CN. This NZ can be written as CZ minus CN. So then CZ value from the directrix, first one, 1 plus 2 do 1 plus 2, we get that one A by E, and the Cn is nothing but x1. Why? Because of this is the point P, x1 comma y1. So this length is x1 and this length is y1. So that is, we'll get PM value is A by E minus x1, A by E minus x1. Then now, so we know that we solve from the conic definition, that is SP by PM equal to E, that is SP equal to EPM, squaring on both sides, you will get SP square equal to E square PM square. Then that is SP square is nothing but, what is the S value? S value we can take from the second one, 2 minus 1, A comma 0, and the P value is nothing but x1 comma y1, x1 comma y1. So then just substitute. So this is SP square, distance between 2 points, and the PM is nothing but the perpendicular distance from P to M. So that is nothing but, so just you have to substitute here. So this is x1 minus AE whole square plus y1 minus 0 whole square equal to E square of, and thus I'm solved this one, PM square in the previous, that is A by E minus x1 whole square. So then next you will get, just expand this one, A minus B whole square, then you will get x1 square minus 2AE x1 plus E square A square plus y1 square equal to E square minus E x1 by E whole square. Then expanding this one will get, this is whole square E square, this is E square. So this will be get, so expanding this one, so then these two will get cancelled. Then we'll get this one, x1 square plus y1 square minus 2AE x1 plus A square E square equal to A minus E x1 whole square. And also you have to expand the right hand side also. You will get this one, x1 square plus y1 square minus 2AE x1 plus A square E square equal to A square minus 2AE x1 plus E square x1 square. From the right hand side and left hand side, same the values of minus 2AE x1, then this will be cancelled. Then you will get in the form this one. So, and I'm taking, this is x1 square and also x1 square, taking to one side. So then x1 square taking common, you will get, this is 1 and this is plus value taking to left side, this will be going to minus, and this is 1 minus E square, and the only y square is there, that is y1 square. So and that these value taking to right side, A square E square, then you will get A square of 1 minus E square. Then just this is in the form of x1 square 1 minus E square plus, so same as it is above, so y1 square equal to A square of 1 minus E square. So then I'm dividing with this one, I'm dividing with this one on both sides. So then I will get, this is 1, and this value A square E square means this value gets cancelled. So remaining value A square, and I will get y1 square by a square of 1 minus e square. Then I'm taking this value as b square equal to a square of 1 minus e square. Just we are assuming this one. Okay, where a should be greater than b. Where a should be greater than b. This is the proof of standard form of an ellipse. This is very, very important for IPE. So please take as it as assignment for today also. Okay, observe this one if you are take a screenshot. Next, so major axis, minor axis. In the previous parabola also we have derived the what is the major axis and the what is the minor axis. Is it? No, sorry. So in major axis and the minor axis. So major axis means if a is greater than b, a dash is called the major axis, b dash is the minor axis, vice versa, a is less than b. So if a is less than b means major axis changes minor axis change major axis. Here these are respective for the a is greater than b, and a is less than b means this will be going to major axis, this will be going to minor axis. Okay, now the line segment a dash and b dash length 2a. So we are solved in the proof. Then b dash is nothing but 2b. So is called as axis of the ellipse. These two are called as axis of the ellipse. So see this figure. So this is a plane. So this is an ellipse. So which is containing a dash as the major axis, b dash as the minor axis. So this is the length of the a dash. So length of the a dash, that is nothing but 2a, and this is length of b dash, that is nothing but 2b. This is like this. Observe this one now. So here a dash is nothing but major axis and b dash is the minor axis. So where a is greater than b. If the a is less than b, then major axis going to minor axis going to major axis. So this value, not coming. So here if a is less than b, will get like this. So which is lies on the y-axis. So and also it has a symmetry. It has a symmetry property. Okay, we'll discuss after that one. Okay, this is the major axis and the minor axis. And next one. So one proof is there. So this is the plane. So this is an ellipse. Let's focus. Then a chord. Chord means line joining 2 points of the ellipse is called a chord. So this is chord. So here this is called line joining 2 points of the ellipse. That is a chord of an ellipse. Next. So focal chord, which means which is passing through the focus of the ellipse, is called as a focal chord. I'm taking here also you can draw in the focal chord. So lattice rectum, a focal chord which is perpendicular to the major axis. If I'm taking this is major axis, this is a perpendicular. If it is on the y-axis, then I will get like this. Okay. So a focal chord perpendicular to the major axis of the ellipse is called lattice rectum. An ellipse has 2 lattice rectums. Ellipse has 2 lattice rectums. I think you are all are getting. So like this. Okay. So observe once again this figure. So this is lattice rectum. This is also lattice rectum. Okay. This is chord. This is focal chord. This is L dash, L1 dash. So nature of the curve. Equation of the ellipse in the standard form, x square by a square plus y square by b square equal to 1. This is nothing but This is nothing but A is greater than B is greater than 0, equation number 1. So the curve is symmetric about the coordinate axis. So curve is symmetric about the coordinate axis. So you have to take this part is equal to this part. So if you take with the y-axis, this part is equal to this part. So that is the symmetric. So the curve symmetric about the origin O, and hence O is the midpoint of every curve as axis. So that is of the ellipse through O. Therefore, O is the center of the ellipse. Then this is called as center of the ellipse. Okay. So next, if you put y equals 0, you will get x square equal to a square. This value should be 0. So then x square equal to a square, you will get x equal to plus or minus a. Similarly, thus the curve meets x-axis, that is nothing but principal axis at 2 points, that is this value is minus a comma 0, this value is a comma 0. Hence the ellipse has 2 vertices. The axis a dash is called as major axis. So previously the length of the major axis is nothing but 2a. So if you put x equal 0, you will get y square equal to b square, that is y equal to plus or minus b. Thus the curve meets y-axis. This is another axis at 2 points, that is 0 comma b and 0 comma minus b. The axis b dash is called minor axis. The length of the minor axis is nothing but 2b. The length of the minor axis is nothing but 2b. Okay. Next, so the focus of the ellipse. The focus of the ellipse is nothing but s is a comma 0. We are proved in the standard form, that is a comma 0. The image of s with respect to minor axis, that is this is, if this one, so here, so this is the image line. So and this, if we have s here, then we'll get same distance, that is s dash. So this value is positive x-axis, this value lies on the negative x-axis, this value is a comma 0, then this value can be minus a comma 0. What is saying that? So s dash is called the second focus of the ellipse. S dash is called as the second focus of the ellipse. The directrix of the ellipse is nothing but x equal to a by e, what we are proved in the standard form, and the image of x equal to a by e with respect to minor axis, that is y-axis, that is x equal to minus a. So similarly in the above figure, so the line x equal to minus a called second directrix of the ellipse. Okay. Next, from 1, so x square by a square equal to 1 minus y square by b square. X from 1 is nothing but x square by a square plus y square by b square equal to 1. From that one we are solving for x, then x equal to x square equal to a square by b square minus y square, then x value is plus or minus a by b under root of b square minus a square. Similarly, I am solving for y, then y square by b square equal to 1 minus x square by a square equal to y square equal to b square by a square of a square minus x square, which is y equal to plus or minus b by a under root of a square minus x square. So this is the equation number 2. These two are taking as the equation number 2. Then if y is real, the values lies mod x is less than or equal to a. Why? Because of this value a square minus x square. A square minus x square can be written as a plus b. So that is the condition. This should be greater than or equal to 0 means, so this can be written as a plus b into a minus b, which means a plus x into a minus x. So then these two values should be positive. These should be positive. Otherwise, any one of the values should be 0. So that's why we can get these values. So that is mod x is less than or equal to a. Similarly, for x is real, then we'll get b square minus y square is greater than or equal to 0. Then it implies this value, and y is less than or equal to b. This is mod y. So this is a condition. So thus y has real values only when in the previous one, that is minus x minus a is less than or equal to x is less than or equal to a. Similarly, x has real values only minus b is less than or equal to y is less than or equal to b. Thus the curve lies completely in the rectangle. The ellipse completely lies in the rectangle, like this. Sorry. Okay, this is this is plus a comma 0, this is minus a comma 0, this plus b comma 0, this is minus b comma 0. So then therefore the ellipse is a closed curve. What we are saying, that ellipse is a closed curve. So any curve zero comma 0 of the ellipse is are the points x comma y minus x comma y simultaneously lie on the curve. Okay, lie on the curve. Any curve C 0 comma 0 of the ellipse is bisected at the point C for the points x comma y minus x comma y simultaneously lie on the curve. The center of an ellipse is defined as the point of intersection of its axis of symmetry. So there, that is nothing but saying that symmetry. Therefore, center of the ellipse is nothing but C. Nothing but C. So next, length of the lattice rectum. So we have to find the length of the lattice rectum. For this one, let L and L dash be the ends of the lattice rectum passing to the one of the foci of the S of AE comma 0 of the ellipse. Then x square by a square plus y square by b square equal to 1, where a is greater than b, which is the equation number 1 I'm taking. Then since L dash, the coordinates of L and L are equal to 2e. L and L are equal to 2e. That is, I'm taking L as AE comma y1. So this is nothing but I'm taking this here, focus. This is a lattice rectum and this value is nothing but, here the focus is AE comma 0 and this point is AE comma y1. So AE comma, this length is AE. So this is y1 length. I'm taking this is AE comma y1. A comma y1. So just substitute the value. This is the lies on the parabola. Then we can substitute the value of L value. Then we'll get a square by a square plus y1 square by b square equal to 1, y1 square by b square equal to 1 minus a square by a square. So just take into right side value, then you will get y1 square by b square equal to a square minus a square by e square, which is nothing but y1 square by b square equal to 1 minus e square. So this value gets cancelled. So then you will get this one, and y1 square value as b square minus 1 minus e square. Then y1 square value is like that. So what we take here, so in the first one, a square of 1 minus e square in the standard form. So what we take in that, a square of 1 minus e square equal to b square. So just I'm substituting this value. So here this value is there. Only we want to this value, then you have to take this value is the right side, then this will be b square by a square. Just I'm right here. So then y values, this is that one. So next, y1 square equal to b power 4 by a square, y1 equal to plus or minus b square by a. This is the point of y1. So which means ae comma, so b square by a. So L value is ae comma b square by a. So this is a positive value, and if we are taking in negative, that is nothing but minus b square by a. But this is ae comma minus b square by a. This is the end points of the lattice rectum. Okay, next. So length of the lattice rectum is nothing but just we have to find the distance between these two L and L dash. That is nothing but x1 minus x2 whole square plus y1 minus y2 whole square. So then substitute ae minus ae whole square is nothing but 0. Similarly, minus b square by a minus b square by a, which is nothing but minus 2b square by a. So just simplify that one. You will get 2b square by a. Length of the lattice rectum is nothing but 2b square by a. So length of the lattice rectum is nothing but 2b square by a for the ellipse. For the ellipse where a should be greater than 0. If a should be greater than 0. So if a is less than a is less than b, then you will get 2a square by b. So we can prove that one after that, after this one. So we can so then I'm saying that the coordinates of the four ends of the lattice rectum. If I'm taking in the lies ante s, so this is I'm taking s, L value as ae comma b square by a. Similarly, L dash value ae comma minus b square by a. Similarly, I'm taking, so here observe this one. So this is L dash value, this is L value. So these 2 points are like respect to this one and this one and this one. These values, these two values are respect to this one. If what I am saying thus in the previous, the b is less than a, b is greater than a, then we'll get this value. You can prove this one from the above theory. So you can do this one. So as usually we can get this is a square by b comma b, that is L dash b, a minus a square by b comma b, and similarly L1 a square by b minus b, L1 dash is minus a square by b minus b. So next, so equation of the lattice rectum, x square by a square plus y square by b square, where a is equal to 1, where a is greater than b, through the s is, if x value, this one, x equal to a, then s dash value, that is nothing but minus a in the similarly previously proved that one. And similarly, if b is greater than a, so then y substitute y equal to b by e, then y by s dash, which means y equal to minus b by e.
BE,
So
sir. Minus BE.
yeah, yes, yes. So the equation of the lattice rectum of the ellipse x square by a square plus y square by b square equal to 1, where a greater than b, through the s is x equal to ae, and through s dash is x equal to minus ae. So that is, and the second one is if b is greater than a, the equation of the lattice rectum of the ellipse x square by a square plus y square by b square equal to 1, through the s is y equal to be, and through s dash is y equal to minus be. Okay, next. So we have to prove this. This is the most important problem, better than the standard form of ellipse. So this is the repeated question for IPE. So then what is given that if the equation, if the point P x comma y be any point on the ellipse x square by a square plus y square by b square equal to 1, where a is greater than b, whose foci are s and s dash, then sp plus s dash p equal to 2a. Just we have to prove that length of sp and length of s dash p equal to 2a. So which is nothing but 2a is nothing but the, here this is major axis. I'm saying that this is major axis. So why? Because of a is greater than b. If a is less than b, this is, I'm saying this is minor axis. Okay, next. So this is proof for this one. So given equation is x square plus y, x square by a square plus y square by b square equal to 1, where a is greater than b. So I'm taking this figure like this. So PB any point lies on the, so these are directrix. So observe this one, students. So here z dash a dash s dash b dash p is any point lies on the parabola. Okay, so next. So here what is saying that s and s dash be the foci, and z m and z dash m dash be the corresponding directrix. So z m, I will draw m value. So then join sp. Sp means, see this. So joining sp. Okay, next. So draw the PL perpendicular to x-axis. Draw the perpendicular to x-axis from P. So M dash be the perpendicular to the two directrix, like this. So this is a figure. Okay, next. So by the definition of conic, SP by PM equal to E, then SP equal to EPM, SP equal to ELZ. Why I'm taking ELZ? Observe this one here. This value PM equal to LZ, this value. So I'm taking the next one. So here this is L, this is Z, this is P. I'm taking this one. So this is M. So this is PM, length equal to LZ. Please observe from the figure. So then PM equal to LZ. This is center C. So then we can write SP equal to E of CZ minus CL. So I'm taking this total value minus this value. Then I will get again LZ value. This is CZ minus CL. Then CZ value, we proved that one. That is the Directrix equation. So that is A by E. CL value is nothing but X. That is nothing but we are taking X comma Y. Any point lies on the ellipse. Sorry. That is SP equal to E of A by E minus X. Then just to multiply with E, then you will get A minus XE. This is SP value. Similarly, I'm doing S dash P, that is EPM. So this is taking to left side, you'll get SP equal to EPM LZ dash. LZ dash means, so here L Z dash value is here. So LZ dash. Then I'm writing C's this value. Wait. So this value LC plus CZ dash. So LC value is X, CL value is X, and CZ value is minus A plus A by E. So the value is A by E. Then S dash P equal to E of X plus A by E. Then you will get S dash P equal to A plus XE. Then, so just we have to find the 1 plus 2 only. What is asking the question? SP plus S dash P equal to constant value. So just you have to add that one. Then SP plus S dash P equal to A minus XE plus A plus XE. Then you will get, this will be get cancel. You will get 2A. This is the constant value. And this is nothing but major axis, where if it is A is greater than B, A is greater than B. If B is greater than A, this is called as a length of the minor axis also. Most important problem, students. Please practice this one and also take as a assignment. Next. So one problem is there. So find the equation of the ellipse with the focus 1 comma minus 1 equal to 2 by 3, and the Directrix value is X plus Y plus 2 equal to 0. Then this is value, Directrix value. Just let P be any point lies on the ellipse. Then SP by PM from the conic definition. Then just you have to substitute the values, SP value and the E value, PM value. PM value is nothing but the perpendicular distance from the point to line equation. What is the point? That is 1 comma minus 1, and the 2 by 3 is the E. Just squaring on both sides. Squaring on both sides, you will get 9. 2 by 4 is nothing. 2 by 3 is nothing, but we are squaring here. So then you will get 4 by 9. Then expand this one, 9 of X minus 1 whole square plus Y plus 1 whole square equal to 2 of X plus Y plus 2 whole square. Just you have to expand this one as A minus B whole square, this one as A plus B whole square. This is A plus B plus C whole square. Then you will get these values and simplify. So 9 of X square minus 2X plus 1 plus Y square plus 2Y plus 1 equal to, this is 4. This is 4. I think this is 2 only. Why? Because of mouse. So here 4 by 3.
The denominator, with the denominator, it will get cancelled, sir. That's 2,
yes,
correct?
Yes. Yeah. I will. I know. So this will be get 4, and this value is root 2. This value is root 2. Squaring means this 2. This is 2 only. So this 4 by 2 is nothing but 2. Then expand this one, 2 of X square plus Y square plus 4 plus 2XY plus 4Y plus 4XY. So then expand this one, multiply with 9, 9X square minus 18X plus 9 plus 9Y square plus 18Y plus 9 equal to X square plus 2Y square plus 4XY plus 8Y plus 8X plus 8. Then simplify that one. Then the required equation is nothing but 7X square minus 4XY plus 7Y square minus 26X plus 10Y plus 10 equals 0. This is the equation of, required equation for the given data. So focus 1 comma minus 1, and E is the 2 by 3, and the X plus Y plus 2 equal to 0. So this is the problem solving. And this is the assignment for today. Square by A square plus Y minus K whole square by B square equal to 1. Given following data. Here, what is this? What is here? So center value. So 2 minus 1 and the 2 comma minus 5. So which means one end of the major axis, which means he is given that this one. So this point is given that, and this point is given that. Just you have to find the value of this one. This is nothing but A. So this will get A value, and the E value is here. So from B square equal to A square of B square equal to A square of 1 minus E square. Then you will get B square value. Just substitute the values in the required equation. Similarly, this is the one end of the minor axis, major axis. Then passing through 8 comma 0. What is the difference between here? Given that e value, but he didn't given that here e value. Just you have to substitute the x square by a square. So what you have that one, just to substitute x value as 8, y value as 0, then you will get a value or b value, then substitute the values. So center 0 comma 3 e value, and semi minor axis is nothing but, if a is greater than b, the value is semi minor axis is nothing but b. If this is a, if a is greater than b, this minor axis is b. So if a is less than b, that is minor axis is a. Center same 2 comma minus 1 e equal to 1 by 2. Length of the lattice rectum is nothing but 4. Length of the lattice rectum is nothing but 4, means 2b square by a is nothing but 2b square by a is nothing but 4. Then you can solve this one. Okay, you will get a condition between the b and a. Then you can solve these problems. So this is assignment for today. So this is end for today. So I think all of you getting ellipse. Okay, thank you one and all. Thank you, ma'am.